What is happening, everyone? My name is Griffin Furlong. I'm really excited about this series. It is the land development series. I made a previous video that gave an introduction to land development, but now we are actually diving into more of the details. This is going to be a very comprehensive series. I can't wait. It's going to take a while. There's going to be many videos, but I think at the end of it, you will have a better understanding of what it takes to work through a project as a land development engineer. But in today's video, we are going to dive into the due diligence effort of a land development engineer. And what we're going to do is we're going to review the documents that we typically receive from other consultants. This includes a survey, topographic survey, geotech report, traffic study, and a phase 1 ESA, which is really just an environmental report. We're going to walk through each type of document we receive, why it's important, and what I typically review when I receive those materials. I want to explain why this is important and why you shouldn't overlook this first episode. So due diligence is important because it is the very first step of the project, and we have to make sure as the land development engineer that we have everything we need to not only succeed, but to design our site to actually comply with the code of the county that we are working in, because every county has a particular land development code and design manual, and we have to make sure that we are following the county's plan for this parcel of land. But I'm ready to dive into it. Let's get to it. All right, so this is going to be our practice project for the entire land development series. We have received the survey from the surveyor, and we are going to take a deep dive into what we should be looking at, and perhaps, we might learn a little something about the site, the characteristics of the site, what's existing. And the reason why a survey is important is because you have to have it. You have to have a survey. Most, if not all, municipalities will require a survey of the property. Now, there's different types of surveys. So one type of survey is a boundary survey, which is what we are looking at here on my screen. Now, there's also a topographic survey, which we will be diving into right after this. Now, a boundary survey is important because it helps determine the property lines and define the true property corners of a parcel of land. Now, I do have to give a disclaimer here. You're going to see a lot of red boxes and things that I've taken out of the documents that we're looking at. Again, this is for educational purposes only, and anything I mention in this video should be taken with a grain of salt because every municipality is different. Every professional engineer is different, project manager, client, everyone is different in this game. And I'm just giving a forewarning that you're going to see a lot of different red cross marks and stuff because I am removing a lot of that personal information. All right, but let's dive into it. So what can typically be found on a boundary survey? I think the first thing that crosses my mind is definitely, you guessed it, the actual boundary of the property. Now, if we examine this darkened boundary of the property, we notice a lot of different labels here about L27, L26, C16. Well, what are these? These are lines and curves that are defining the actual property boundary. And so this is what the surveyor is putting together to actually define the site. Now here we have some line data tables and curve data tables that defines the bearings and the length of these curves. Not so much important for me, but what is important for what we're about to do is definitely this property boundary. This is our limits, guys. We can't do anything outside of these extents without needing some sort of coordination with another property owner or easement, and we can get into that later. So what else can we find on a boundary survey? You can also find the different sections, townships, and ranges, and really all that is think of a section as an area that is nominally 1 square mile on a rectangular grid. Think of it just as a system of divvying up the land in digestible chunks, if that makes sense, from a county or a planning perspective. That way we can actually go and identify where this section of property exists. So that's what you'll see often. You'll see sections here. You'll also see ownership, and again, I've canceled a lot of these names out, but you'll see ownership lines. So there's an owner of this property. There's an owner of this adjacent property there. Also, most importantly, that north arrow in the scale is always important. But now let's go over here, and this is a very important piece of a boundary survey, and this is known as the legal description. A legal description is a written statement that delineates the boundaries of a piece of real property. It is the very precise location and measurement of a real property. Now, since a legal description has to define the actual geometry of the boundary, it always starts with a beginning point and it makes its way around via the line and curves, finally to very back right to the beginning. The legal description will also contain the acreage of our site. So our example project, we are going to be dealing with a 66.941 acre site. I can't stress how important a boundary survey and legal description is. I mean, when you are permitting through a county, you will always need this information. This is just one of those check boxes that you'll always need and that you have to make sure that the surveyor is 100% on. If any sort of boundaries want to change, for instance, if a client wants to buy more property and just incorporate the adjacent property into this boundary, then that will require the boundary to get updated and the legal description to be updated. So always be thinking about that. So now we're going to dive into the surveyor notes. We're not going to go through each one, but I want to point out some of the very important ones. So let's see what we got here. The first thing that came to my mind was the flood zone. So this is always extremely important, guys. We have to, right when we receive a survey, we need to identify if the property is in some sort of FEMA flood zone. Now, you don't necessarily need a survey to identify this. You can actually go online to a FEMA ferment map and you can locate your property and see if your property is within a floodplain. But that'll be on a separate video. This is all about reviewing a survey. So in this case, our survey mentions that there is a flood zone AE and X. Now, the big difference here is that zone AE is the FEMA flood zone designation for areas that are subject to a 1% chance of flooding annually, while zone X is actually an area of minimal flood hazard, is pretty much depicted as being above the 500-year flood level. So zone X, the way that I read it is that we're good, we're not in the floodplain, but anytime I see a zone AE, guys, we're in the floodplain, or even a zone A. A zone A is very similar to an AE, except that a zone A, the elevation actually isn't established from FEMA, and it's up to the civil engineer to define that zone. Another really important thing is knowing your datums, and that will be covered in your survey. The surveyor will always point out the datums that we are using, not only from a horizontal perspective, from a vertical perspective. Guys, the reason why this is important is because datums can throw off your whole site if you use the wrong one. Before I even dive too deep, so a vertical datum is a surface of zero elevation to which heights of various points are referenced. So think of it as just a starting point of where to base elevations from. So typically around the site, somewhere there's some sort of benchmark. Now, two of the most common vertical datums are the NAVD 1988 and the NGVD 1929. Now, I'm certainly not a licensed surveyor, so I can't go really into the depths of it, but the most important thing for land development engineers is that you really need to be 100% on your datum, work with your surveyor to make sure that you are in fact in the right datum. So I think we've covered the very basics of a boundary survey, and now we're going to walk into the topographic survey. All right, so let's move on to the topographic survey, and let's just kind of dive right into it. So this is closer to the bottom right of our site where there is an existing roundabout. So right now our survey is pointing out that there are existing asphalt pavement sections. There's an existing 6-foot concrete sidewalk right there, back of curb, and I know what you're thinking. You're probably seeing all these lines and it's pretty scary. There's a lot of information going on here, but let's just kind of walk through it, guys. So again, the first thing that we're finding are some existing features here of our site. So there is an existing road, an existing roundabout that we're going to be tying into. We also have some elevation points here. Anytime you see these, X symbols, those are just spot shots. And these were actually gathered from the surveyor. So the surveyor goes out there and they get their theodolite or wherever instrument they're using, whether they got Rodman or whomever, they're going out there and they're actually collecting elevations on our site. What we also have is some existing drainage infrastructure that you can barely see here. It's kind of shaded back. We have a 30-inch RCP. We also have looks like maybe a manhole. It's not clearly define what it is, at least this one is over here, curb inlet. Now it looks like we were given the top elevation and then the invert elevation of those pipes. So we got some existing infrastructure here. Let's see what else we got. So we got some verbiage right here that this boulevard that we have is a public right-of-way, 142 feet right-of-way width. Now essentially what public means is that this is owned and maintained by the municipality that owns this right-of-way. So what is right-of-way? Well, right-of-way is the legal right established by usage or grant to pass along a specific route through grounds of property belonging to another. So if this is public right-of-way, everyone in the public here has access to this. You can freely use the road. You can freely use the sidewalk. It is a legal right of pedestrian, vehicle, or ship to proceed over others in a particular situation or place. Now, if it was private, that means that there are particular uses that might not be allowed for the public. So what else do we got here? It looks like we have some top of bank callouts, so there must be a pond. We have an edge of water. So we have some survey. Looks like we have a pond here. Now let's read some of these contours. Maybe we can find something out. So we definitely have some sort of bank here, and I'm seeing that because they're calling out a top of bank right there. And that's going to be really important as we move through this project. So let's actually study some of these contours. That way we don't skip it over. So one thing that I'm noticing right off the bat is we have a really big ridge right here. So the reason why I know that this is a ridge is because I see these elevations falling down here. And what I mean by down is, look at our elevations. We're at elevation 52.9, 52.5, but then we go from 52, 51, 50, 49, 47. So, you know, all of this water, if it rains, is actually sheet flowing, some of it into this pond, and then some of it into what looks like a wetland line. So these wetland lines were established, and that's a really important thing. At least in Florida, wetlands are critically important, and we will dive into that more once we look at the environmental report. Yeah, those are really important lines to call out in this survey. It doesn't look like we have any existing drainage on our site, meaning any existing drainage infrastructure or utilities. A lot of times when I'm looking at a survey, I'm looking for flood zone elevations, I'm looking for highs and lows and elevation of the topography. I'm also looking for existing features, like maybe existing mains that are on our site, or maybe there's like a gas line or oil line running through it. A lot of times I'll try to find existing drainage features. Maybe there's an existing 30-inch RCP on our site. I'm trying to identify kind of what we're going to be demolishing, and let's keep walking through. Right in the middle of our site, we have a big wetland conservation area, and it looks like the surveyor picked some points along that wetland line, which is good. Looks like we have another ridge here because I see elevations of 43 going all the way down to like 41 and 42. So water sheet flowing into this wetland. That's how I can kind of tell what's going on. Let's see if the surveyor picked up any maybe existing utilities in the area. I can tell that there are some existing utilities. It looks like I'm just seeing a lot of these gate valves. So if you ever see this little, I don't even know how to define it, this little symbol right here, that will always be a gate valve. Typically. Now, if it's showing a gate valve W, that's most likely gate valve water. If it's showing gate valve FM, that might be a gate valve of a force main. Let's see if there's a legend. Now that's the really big important thing here, is that we need to understand our legend, and that could help answer a lot of questions. And here we go. So we got W, yep, so it was in fact a water gate valve, reclaim water gate valve, irrigation control, and so on. So understanding your legend is very important. I guess last but not least, we also did pick up a tree survey. A tree survey is really important, especially because municipalities typically will require some sort of mitigation for removing trees. And this is why we work hand in hand with the surveyor, a landscape architect, and an arborist to understand the quality of the tree. Let's say, for instance, if it was a very beautiful, large, grand oak, we would want to make sure that we protect that tree. And a lot of times, there's mitigation requirements or requirements for not even being able to remove that tree. But again, every county is different, so always consult your county. But this tree survey is really important for our tree mitigation calculations that we'll be putting together. Also, a tree survey is important because a lot of times you can get these very beautiful trees and you can actually incorporate them into your site design. We had one project where we had some very beautiful grand oaks at our entrance, and we were able to modify our site plan to give this sort of canopy road feel, and it was really cool. So that's my quick review of a boundary and topographic survey. But now it is time to move on to the Geotech report. And I am going to cut right to the chase here. A Geotech report is important because it helps understand earthwork. It helps understand the requirements for our foundation, for our buildings, our pavement sections. Everything that we're going to be building on this site is going to be laying on the soil that's underneath it. It's important that we understand those characteristics, especially as it relates to the structural foundation and integrity, and as well as the actual seasonal high waters and groundwater table, especially for the land development engineers. For the land development engineers, we are designing the stormwater management system for the site, and it's absolutely important to know where that groundwater table exists. The reason why this is important is because if we do not know where the groundwater table or seasonal high water tables exist, how do we know where to design our road elevations and our home elevations? Anytime that we'll get water in our structural pavement sections, water ends up weakening those sections and causes failures, like the potholes that you might see driving around in your neighborhood. So the better that we can understand these water levels, the better that we can understand the soil characteristics to see if we can actually use those for structural foundations, the better. Now, a few things that I'm typically looking for in a geotech report are always the soil borings. The soil borings are collected by the geotechnical engineer, and a lot of times we'll create a map of where we want to get borings from. And typically we'll get borings of where we're proposing a roadway section. Sometimes we'll even get a couple borings of some of the lots that we're proposing. And definitely we'll always ask for a bore within the pond, and sometimes even multiple. So in this case, I'm diving right into the boring plan that we provided to the geotechnical engineer. And the geotechnical engineer will actually go out on site and collect all of these borings. Now, these borings are big auger borings that are drilled right into the ground where soil samples are collected. Now, in this case, I believe that these borings were roughly 25 feet deep, perhaps 48. Okay, some of them might have been 10 feet deep. So everyone's different, it always depends on your client, what your client is willing to go get. The deeper the boring, the more expensive, the more work, the more studies. But these borings can range anywhere between, 10 feet in depth, and you can even get up to 30 feet and probably even longer, but I'm not a geotechnical engineer. Now, before we dive into borings, we can't skip over the narrative of the report. So the narrative of the report is very, very important. The reason being is because this is the geotechnical engineer's recommendations on what we should do based on what they analyzed. And a lot of times you'll find really important information in here about your pavement section design. So let's say for this residential neighborhood, we're proposing roads, right? So a lot of times they'll give recommendations on what we should use for a pavement section of subgrade, base, and asphalt. And they'll also give some recommendations on the separations between the base material and the seasonal high water. Because like I said, if that seasonal high water starts encroaching into the subgrade or base material, that's when you start seeing problems out in the field and when you start seeing pavement failures. Also within this narrative, you'll find really important groundwater information, especially if it's Florida or anywhere where there's high groundwater table. So in this case, we're looking at a table here of some boring locations with the ground elevation, the groundwater depth, the depth to the estimated seasonal high, and then the seasonal high. Now, this is actually a sneak peek into potentially maybe the third episode of the land development series where we dive into the stormwater management system design. All of this information is going to be very, very handy as we are designing our stormwater management. But I wanted to show you some of the pieces of information that we gather from the geotechnical report. Now, it looks like seasonal high water is averaging anywhere between 1 to 2 to 2.5 feet. So this seasonal high water is pretty high, and that stands out to me because that means that we're going to have a certain separation from our road material in the seasonal high. That means a little bit more fill. And fill is how much dirt we are actually stacking on this existing earth to build up our site. So let's kind of just take a look at a particular boring. So here we have this proposed pond PB6. So that's pond boring number 6. So let's try to identify where pond boring number 6 lives. Now RB in this case will stand for the road boring. So we're looking for PB6. All right, so here we have PB6. Let's take a look. This is really important for a pond because we need to understand what type of soils we're going to be getting out of this pond. Hopefully we're getting really good sands and not clays, but let's kind of identify, and I'll talk about why we're looking for sands here in a second. So let's look at PB6. So here on the y-axis is the elevation in feet. So instead of just giving us depth, they gave us an elevation in feet here, which is actually pretty nice. It looks like that groundwater table is pretty high. So let's confirm that that's groundwater table. But yep, that's groundwater. So it looks like we got a legend. Let's work this out together. It looks like we have soil 1, 2, 3, 4, and then we got some 7B. So what is 1? Very dark gray, slightly silty to silty fine sand, SP-SMSM. What else do we got? Looks like we have some sands, SP3. We got some sands, SPSPSM. Okay, silty organic fine sand. Now, you're probably wondering, what the heck are all these SPSMs, especially if you haven't even gone into a geotechnical class yet. Well, that's why we have a geotechnical engineer, right? They'll clearly outline what some of this stuff means. So let's actually go find this narrative where they talk about some of this stuff, because then we'll be able to know what we can use for structural fill and, kind of get their opinion on the soil that we're seeing. So it looks like the majority of the soils encountered in the boring strata 1 through 4, SP to SPSM soil types can be categorized as relatively clean to slightly silty clay fine sand deposits based on the USCS. This is the most important, and this is when you take notes as the land development engineer. This is so critical. The reason why we're diving into a geotechnical report and the reason why you should absolutely understand 100% of it is because it can throw off a project. So now let me get back to this sentence, because this is an important sentence. These soil types will be suitable for reuse as fill with minimal processing to control moisture contents. Boom. Anything between that strata 1 through 4. Remember how we were looking at that map again? I guess let me go back to it. PB6, so 1, 2, 3, 4. Those are all the stratums, right? Those are the strata. So it looks like we have 1 through 4. So where we're digging that pond, we're going to be getting good soils that we don't have to go mix in with other soils. We can actually just take that soil and it could be used for structural fill. Now what the geotechnical engineer called out was number 7 here, which is black, slightly silty organic fine sands. And let's see if there's any more language on these types of. Let's see if there was anything else regarding these stratum. All right, what about stratum 5? Here we go. On-site suitability. So stratum 5 as well as portions of stratum 6, clay fine sand. Yada, yada, yada. Clay fine sand is considered suitable for pavement and structural fill, provided that the plasticity characteristics are acceptable. These soils are considered usable for select pavement and structural fill where the silt clay content is less than 15 to 20%. What does that even mean? Can we use it? Can we use it for fill? Well, that could be a very good question to your geotechnical engineer. As we are reading these reports, it's really important to get 100% with your experts. I'm not a geotechnical expert, but by the sentences that I'm reading, it looks like we can use it for our pavement sections and the structural fill under the buildings, but it looks like stratum 6 is actually just off the books. These soils should also be avoided as used for structural and pavement fill. And then stratum 7, last but not least, could only be used with landscaping areas to the elevated organic content. So again, it looks like stratum 6 and stratum 7 should not be used for structural and pavement fill, which is really important because let's say if we are cutting these ponds to get the earthwork, right? Let's go back to that map. If we're cutting all of these ponds, like pond D, whatever this pond is, and this long boy right there, we need to make sure that we're getting quality soils and that we're placing these ponds in a good place to where we can receive the good soil. Now, that's why it's important that we go through these different bore logs, because we have to understand if we're taking out the stratum 6 and 7 soils. Because once you take those out, you have to do something with them. And since we can't use them for any of the fill under the roads or under the lots, we have to be strategic, and that means we're either exporting it and hauling it off somewhere. We could potentially sell that dirt, but then again, you're not really selling great dirt. Or perhaps you work with your landscape architect and use some of those nasty clays and help put those in some landscape buffer areas or berms, or maybe in some of the top of banks. That's honestly all I have for this geotechnical report. Again, the list of items that we are typically looking for in a geotech report are the soil borings. We're trying to identify which bores have nice structural fill so we can retrieve that structural sands to put under our pavement sections, our buildings. We're also trying to identify the seasonal high water levels in the groundwater table. We're looking for a general pavement section recommendation from the geotechnical engineer. We're also looking for anything crazy. I mean, sometimes with sites you can have karst conditions, meaning there could be a potential sinkhole on site. We definitely need to know that and be aware to tell the developer that's going to develop a neighborhood so that homes aren't just getting destroyed by a sinkhole. All right, now we're going to be moving on to the traffic report. Now, why is the traffic report important? The traffic report is important because it helps determine any sort of offsite requirements that we need into the project. It also identifies any specific improvements that we need to make. So think of it like this. Think of conceptual, right? You're about to build an entire neighborhood where you're going to increase the traffic into the project. The traffic engineer's job is to make sure that whatever the client wants to build and create, that those traffic patterns aren't causing any disruptions into the existing infrastructure there. This includes lane widths, right-of-way widths, making sure you have the necessary turn lanes, making sure there's actually not any future CIP or capital improvement projects, because a lot of times these communities can be planned out and there's a specific comprehensive plan in place that's like 5, 10, 15 years out, and any sort of project that gets proposed or any sort of increase in traffic causes a trigger in what you need to do. For instance, this neighborhood that we build could potentially trigger a need for a specific turn lane or perhaps some traffic signalization. Now, I am no traffic engineer, but as a land development engineer, I need to know if there are any required improvements, because I'm going to be the one that generates the plans needed. So for instance, if the traffic report came back saying that we needed, let's say, a turn lane, or that we need to widen the existing off-site road by 2 feet, well, I have to incorporate that into an off-site set of plans in order to meet the county's requirements. So as I'm going through this traffic report, the biggest thing that I'm looking for is seeing any sort of trigger point, like, hey, because of the traffic that you're receiving, because of the proposed traffic, you'll need a new roundabout, or you'll need something. So let's dive into it. So remember that roundabout that we were looking at in our survey? It looks like we'll be able to use that for access because the traffic engineer says there is not anticipated to be any improvements. So we don't have to make any improvements to this roundabout, which is good. Roundabout includes a stub out for the access to serve the property. Perfect. So we have access to this. And what's most important is that we have proper access. Sometimes you won't have proper access. You might see a little driveway stub out, but doesn't mean that that little driveway stub out is up to a standard. In this case, the county will always have a standard of a driveway or an entrance that you need to meet. I'm always reading the narrative to see if I'm required to do anything extra. I think some of this other stuff is really good information. Sometimes in a traffic report, you'll get the certain type of functionality of a right-of-way. So we have this nice little legend map here that shows the different right-of-way widths, and then if there is on-street parking allowed or not, which is really important. Last but not least, the environmental reports. Also can be known as a Phase 1 ESA, it is telling you everything you need to know about the environmental hazards, environmental risks that you take on this property, and any sort of features on the property, and any sort of native species or protected areas on the property. Sometimes you'll hear this called as a bugs and bunnies assessment, which is detailing all of the protected species on the site. Sometimes you'll even get an assessment where they'll call it a brownfield, which is determining if there's any contamination on site, like oil spills or anything major like that. As far as the land development engineer's perspective, the most important thing that I can gather from this type of environmental report is definitely the existing protected features, for instance, like a wetland or a ditch that may be protected, or perhaps there might be a wood stork nest or some sort of eagle's nest that's protected, and then we won't be able to do construction for a certain period of time. All of these things really matter as we develop our schedules and try to permit these sites. The important thing about a wetland survey and a wetland study is that this could really impact our site plan. We need to know immediately how big this wetland would be, especially that one that we were looking at right in the middle of our site. We have to make sure that this wetland was officially established by a surveyor and environmental scientist. How I'll also use the environmental report is for the land cover. So a lot of times these environmental reports have really good descriptions of the land cover, whether portions of the site have upland forests or agricultural operations, improved pastures. I mean, this environmental report can really dive into the land characteristics that I will need in order to develop my drainage report. So as far as design related information that I need from an environmental report, again, I really study the land characteristics, if they have any nice descriptions of the type of land. Also, the wetlands are extremely important for establishing the site plan. But then there's a whole nother side of the permitting aspect, being the project manager, is that I have to understand if there are any more wildlife surveys that are required, or any additional permitting that's required from an environmental standpoint, because this could potentially impact schedules. For instance, like I said, if there was a bald eagle's nest, I would have to make sure we really understand the requirements for that, and if we are even allowed to build within the vicinity of it, or if we have to start construction at a certain time. Again, that's why it's really important to coordinate with your environmental scientist on the team. That is all I have for today, guys. I hope you learned something new, and I hope by the end of this video that you have a better understanding of the types of due diligence documents that we receive and how a land development engineer actually walks through those particular items. This is an extremely important video and step in the process of being a land development engineer, especially at the start of a project, so we can't shortcut this step. This will help build our foundation as we move through each essential step of our design. You'll soon start to realize the importance of this boundary, of these elevations presented in the survey. You'll realize how important that geotech report comes later on, how that traffic report impacts our design, and as well as how those wetlands shape our site plan. Stick around for more episodes. Again, this is the land development series where we will learn how to start a project from scratch and move it forward through its final design. Appreciate everyone tuning in, and I hope you guys have a good day. Peace out.